Welcome to Smart Learning Point. In today's class, we're going to be looking at how to convert decimal fraction in base 2 to base 10. Are you excited? Let's look at how to do this. So we'll start with the first example, where to convert 0.11 in base 2 to base 10. Okay, so let's write this down first. 0.11 in base 2 to base 10. Okay, so this is what we're going to do. So the integer part or the whole number part is this 0. So any number before the decimal point. So before the decimal point, that is the integer part. Okay, then immediately after the decimal point, we have the fractional part. So let's start from the whole number part or the integer part. So the integer part, according to the place value, this is unit. Okay, so because this is unit, the power on unit is raised to power 0. Okay, so that's the power on the unit, raised to power 0. Okay, then after decimal point, according to place value, we have tenth. So tenth. So the power on this is -1. Okay, -1. Great. Then immediately after the tenth, the next one is 100. In the 100 position, the power there is -2. Or if we go on like we have another digit, like let's say we have 1 here now, the next power is going to be -3. Okay, you get the idea. Good. So we have gotten the power now. So the next thing we need to do now, we take these digits one after the other and multiply them by the base. So the base is base 2. So the first digit we are starting with is this 0. So we take the 0, multiply by 2 raised to power 0. Let's put that in bracket. Then plus, we'll take the next digit, which is 1 times the base, which is 2 raised to power -1. Let's put that in bracket. Then plus the next one is this next digit, which is 1 again. 1 times the base raised to power its power, which is -2. Okay, good job. So now we have 0 times 2 raised to power 0 is 1. Anything that is raised to the power of 0 is 1. So we have 0 times 1 there. Okay, then plus 1 times, then for 2 raised to power -2. Okay, so this is the way I want you to figure this out so you can get it right. 2 raised to power -1. So think of it like this. This negative becomes the 1 on the numerator side. So if you're converting 2 raised to power -1 to fraction, this is the way you're going to do it. This negative here will become 1 on the numerator side. So you write 1 over, then you take the number here, which is 2, and you raise it to the power, which is this 1. You raise it to the power. Okay, so according to this now, you have 1 over 2 raised to the power 1 is 2, because any number raised to the power of 1 is going to be the same number. So you have 2 there. Great. So what if you have 2 raised to the power -2? 2 raised to the power -2, that means you're going to have this minus become 1. So you have 1 over 2 raised to the power of 2. Okay, so this will be 1 over 2 raised to the power 2 means 2 times 2. And 2 times 2 is 4. On and on like that. If you have 2 raised to the power -3, that's going to be 1 over 2 raised to the power 3. And 2 raised to the power 3, 2 times 2 times 2, which is 8. That means 2 raised to the power -3 is going to be 1 over 8. You get the idea? Great. So for this one now, 2 raised to the power -1 is going to be 1 over 2. Then plus 1 times 1 over 4. Great job. So 0 times 1 will give us 0. 0 plus 1 times half will give us half, because any number multiplied by 1 is going to be the same number. So we have half there. Half plus 1 times 1 over 4 is going to give us 1 over 4. Okay, great. So quick one, let's add the fraction together. So we have half plus 1 over 4. So let's add it together. We get the LCM. So to get the LCM, you look at the 2 and the 4. 2 and 4, they are the denominators of these two fractions. So ask yourself, simple question. Which of these is the big denominator? 4 is the big denominator. Okay. Then the second thing you need to ask yourself again, which one is the small one? 2 is a small denominator. Now ask yourself the next question. Can the small denominator go in the big denominator? If 2 can go in 4, take 4 to be the LCM. Okay. Since 2 can go in 4 2 times, it means we can take 4 as our LCM. So we write 4 here as our LCM. Great. So next thing we need to do, how many 2 can go in 4? So 2 can go in 4 2 times. So we take that 2 to multiply its numerator, which is 1. That's 2 times 1, and that will give us 2. So we write 2, then plus, how many 4 can go in 4? That will give us 1. So we take the 1 to multiply its numerator 1. That's 1 times 1, and that will give us 1. So what we have there is 2 plus 1, which is 3. And so we are having now 0 plus 2 plus 1 over 4. So we can write this as 0 plus 3 over 4. Since this is 0, 0 means empty, nothing. So 0 plus 3 over 4 is the same thing as writing 3 over 4. It means our final answer of 0.11 in base 2 to base 10 is 3 over 4 in base 10. That's amazing. So 3 over 4 in decimal, you can convert that to decimal too if you want to. So converting this to decimal is going to give you 0.75. Okay, great job. Okay, so let's look at the second example, where to convert 0.0011 in base 2 to base 10. So let's write this down. 0.0011 in base 2. Okay, first we need to write down their powers. Okay, so we start from the first digit. The first digit is this 0. So since that 0 is on the unit position according to place value, the power on it is going to be 0. Okay, after decimal point, the following digit, that's immediately after the decimal point, the next digit, the power on it is -1. And then after that, the power on the next digit is going to be -2. And the power of the third digit after decimal point is going to be -3. And the last one here is going to be -4. Okay, amazing, good job. Okay, now so we have 0. We start from the first digit. So we write 0 multiplied by the base, raise it to its power. The power there is 0. Put that in bracket. Plus, we'll go to the next digit. 0 times 2 raised to its power, which is -1. Then plus 0 again, which is, this is the next digit. 0 times 2 raised to its power, which is -2. Then after that, we have plus. So the next digit is this 1. So we have 1 times 2 raised to the power -3. Put that in bracket. Then plus 1 times 2 raised to the power -4. Put that in bracket. Great. So we have 0 times 2 raised to the power 1, and 2 raised to the power 0 is 1. So we have that. Plus 0 times 2 raised to the power -1 is 1 over 2. Okay. Then plus 0 times 2 raised to the power -2 is 1 over 4. Then plus 1 times 2 raised to the power -3 is 1 over 8. then plus 2 raised to the power minus 4 is 1 over 16. Amazing. So in case you're finding difficult to get the 2 raised to the power minus 4, so the minus becomes 1 on the numerator side, and the 2 raised to the power 4 is you multiplying 2 times 2 times 2 times 2. That's in 4 places. 2 times 2 times 2 times 2, that gives 16. So it means 2 raised to the power minus 4 will be 1 over 16. Good. Okay, 0 times 1, that's 0, plus 0 times half. Any number multiplied by 0 is 0, so we have 0 there, plus 0 times 1 over 4, that's also 0, then plus 1 times 1 over 8, that will give 1 over 8, because any number multiplied by 1 will give the same number. Then 1 times 1 over 16, that will give 1 over 16. Great. Okay, so these are the two fractions we have. 0 plus 0 plus 0 is going to give 0. So let's add the fraction part. So for the fraction part, again, look at the number and the denominator that is big and the denominator that is small. The big denominator here is 16 and the small denominator here is 8. So ask yourself, can 8, the small denominator, go in the big denominator 16? If 8 can go, take 16 to be the denominator. Since 8 can go in 16 two times, we're going to take 16 to be our denominator. Okay, great. So 8 in 16, that is 2. Take that 2 to multiply its numerator. The numerator there is 1. 2 times 1, that will give 2. So we have 2 plus 16 in 16, that's going to give us 1. 1 times 1, that will give us 1. So we have 2 plus 1 there. Okay, so when we added 0 plus 0 plus 0, it gave us 0. So we can just put the 0 there. So now what we have now is 0 plus 2 plus 1 will give 3. So we have 3 over 16. So 0 plus 3 over 16. 0 is empty. So it means our answer for 0 plus 3 over 16, it will still be 3 over 16. Amazing. Okay, so let's look at the next example. We asked to convert 1.011 in base 2 to base 10. So the first thing we need to do is to write down the powers of all these digits in this number. Okay, so first take out the whole number part, which is the integer part. The integer part here is the number before the decimal point, and that is this 111. Okay, so let's put the power on the 111. So this 1 here is on the unit level, so the power on it is 0, while the place value for the next one, which is this one here, this is tens, so the the power on it is 1. Okay, then for the place value 100, which is this one here, the power on it is 2. Good job. So after decimal point, the place value of the next digit is -1, and then immediately after that, the place value of this one is -2, and the place value of this is -3. Good job. So let's multiply now. So we start from the first digit, which is this 1. So a 1 multiplied by the base is 2. 1 times 2 raised to the power 2. Then plus the next one is this 1. 1 times the base is 2, raised to its power, which is 1. Then again plus, we take the next digit, which is this 1 times the base, which is 2, raised to its power, which is 0. Okay, then plus the next digit is this 0. We take the 0, multiply by 2, which is the base, raise it to its power, which is -1, put that in bracket, then plus the next digit is this 1. So we have 1 times 2 raised to the power -2, and the next one is this last one, 1 times 2 raised to the power -3. Let's put that in bracket. Okay, so 2 raised to the power 2 means 2 times 2. That will give us 4. So we have 1 times 4 there. Then plus 2 raised to the power 1 is going to give us 2, because any number raised to the power 1 is going to be the same number. So we have 1 times 2 there. Then plus 2 raised to the power 0, that is 1. Any number raised to the power 0 is going to give us 1. So we have 1 times 1 there. Then plus 0 times 2 raised to the power minus 1, that is half. Then plus 1 times 2 raised to the power minus 2, that is 1 over 4. Then plus 2 raised to the power minus 3, that is 1 over 8. Amazing, good. So 1 times 4, that will give us 4, plus 1 times 2, that is 2. Then 1 times 1, that is 1. Okay, then 0 times half, that is 0. 0 times any number, we give 0. Then plus 1 times 1 over 4, that is 1 over 4. So any number multiplied by 1 will be the same number. Then plus 1 times 1 over 8, that is 1 over 8. Okay, good. So let's add the integers first. That's the whole number, which is 4 plus 2 plus 1 plus 0. That is 7. So let's write down the 7. 7 plus, then let's add the fraction, which is 1 over 4 plus 1 over 8. So let's get their LCM. We have to, the denominator here is 4 and 8. So ask yourself simple question. Which of this denominator is big? 8 is big. Which is small? 4 is small. Can the small denominator go in the big denominator? Can 4 go in 8? Yes, 4 can go in 8. So we take 8 to be our denominator. So 8 is our denominator because 4 can go in 8 2 times. 4 in 8, that is 2. Take the 2 to multiply its numerator. That's 2 times 1, and that will give 2. So we have 2 plus 8 in 8, that is 1. Take that 1 to multiply its numerator. So that's 1 times 1, which will give 1. Amazing. Good. So we have this. So now we have 7 plus, then we have 2 plus 1 here, that is 3. So we write 3 over 8 there. Okay, so this is what I want you to do. If you use your hand to cover the plus sign, what can you see? Okay, so you should be able to see 7 whole number 3 over 8. So this is the final answer.